I have attention deficit disorder, which means I focus a little differently and I make decisions a little differently in class or at work than some other people. It's often viewed as an intersectional disorder. That is something that's an interplay between some aspects of our biology and some aspects of our modern environment. But when combined with my curiosity, it helped me actually learn and build connections between ideas. This is probably why I ended up falling in love with philosophy. I studied philosophy of mind and philosophy of language, and this made me want to understand the connections between the brain, the mind, language, and our society. So I pursued a PhD in neuroeconomics, which is an interdisciplinary field that combines neuroscience, psychology, artificial intelligence, economic theory. It's trying to understand how we make decisions. And like many of you, I often wonder, are we as humans actually any good at making decisions? I know sometimes I really struggle making decisions or building good habits, and I'm sure you have experienced something similar at least once. The study of human decision-making says that this is universal. We all make inconsistent decisions in some circumstances. Should we eat junk food or healthy food now? Exercise or watch TV? Buy a new car or save for retirement? We often know we should do things for our future selves, but we get tempted to enjoy the moment now. We also struggle with risks or benefits that are very uncertain. We make imperfect decisions over and over again, and they may lead to habits. Of course, these problems emerge collectively as well. For example, we have known for a long time that climate change could create massive disruptions, maybe even be an existential threat. But it took us decades to collectively agree on the risks, and we haven't been able to decide on the solutions or stick to our goals. In fact, it's mostly been business as usual, not going in the right direction. And our technologies complicate things further because they directly influence our decisions. For example, social media often uses algorithms that take advantage of our psychology to keep us attending to them, even if we don't have the time to waste. The same is true for our fossil fuels. It powers our amazing technology, these lights shining on me right now. And yet, it had a bunch of unforeseen consequences as well. So if I asked you right now, what kind of future do you want? What kind of future do we want? What kinds of futures are actually possible? Do you think we would make a good choice? Do you think we could stick to it? We all rely on experience and learned understanding of the world to sort of navigate ourselves towards a better future. But how well do we perceive those possible futures? And how do we know what's actually good for us? Where does our idea of good and bad even come from? As a species, we've faced collective decisions all the time as well. For example, in a relationship, at work, in our societies, our democracy. It's a way that we can make combined decisions, trying to take advantage of our individual knowledge, our individual preferences or desires, but we don't always make these collective decisions very well either. Our collective decisions are often even more influenced by our technologies, and it's a term I want to use very broadly. Education is a technology, therapy, democracy, medicine, along with all of the other things like power plants, electronics, and the wonderful things that make all of the modern world work. I think that many of our decision struggles come from the complex learning processes that are used to construct our minds, each of which learns at a vastly different time scale. Our minds are the product of evolutionary hardware and social and cultural software. To make better decisions, perhaps we need to start with the old maxim, know thyself, good advice that was carved on the temple of Apollo at Delphi a few thousand years ago. So let's start by thinking about how evolution created the human brain. Evolution is effectively measuring how well an animal is adapted to some environment where it finds itself. We call this fitness of the individual. And evolution works by exploring very small changes in those individuals to see which ones survive and reproduce. It's a very slow process, but we can think of it as animals climbing a fitness hill as long as the environment around them stays the same. And evolution works very slowly, but it can explore very broadly because there are many species in many different environments, and they can even compete or cooperate with each other, making the environments more challenging and dynamic. There is a problem, though, as you know. If there's a sudden change in the climate, for example, lots of these experiments may fail, some will disappear, and some other species may start doing better. One of the theories for why the human brain has become so powerful and intelligent is we had a long period of around 600,000 years where we were facing slow but constant change in our environment, which may have pushed us to be really good at learning. Now, let's go back. Around 125 million years ago, the mammalian brain basically had the same architecture that our brains have today. Of course, the brains have changed size, there's been more specializations, but the fundamental organization stays the same. And mammalian brains are good at learning because they use a simple but powerful learning mechanism guided by an internal sense of reward that's used to learn and guide decisions. And mammalian brains use dopamine as part of this process. You've probably heard of it, along with other neuromodulators, and they inform the rest of the brain when something or some place or some action is different or better or worse than we expected. This learning we can think of as also climbing a hill. In some context, you make some choices and we're trying to figure out which ones are going to give you more reward. And of course, we can do this in a bunch of different contexts. For example, the opossum's brain has not changed very much in 100 million years. That means that this reward system is capable of producing a very robust species that can survive for a very long time. The fundamentals of this reward system begin with basic needs: food, water, sex, shelter. But through individual learning, it can build up complex abstract values. For example, capuchin monkeys, who diverged from us around 30 million years ago, they can learn to use tokens to exchange things for food. And in fact, they learn to do it in a way that looks very much like the way humans use money. It looks so much like the way humans use money that they make some of the same economic mistakes. It's also the foundation for a bunch of our modern artificial intelligence. This is AlphaZero, an AI that learned to beat humans at shogi, chess, and Go. And it fundamentally just used reinforcement learning, playing against various versions of itself until it had mastered the games. Of course, our brains are much more sophisticated and capable than an opossum's, but actually a lot of it is because we've learned to abstract. We've learned to do things that have extended our learning in different ways. Around 2.5 million years ago, our evolutionary ancestors started developing technologies, perhaps aided by the fact that the dopamine system actually responds to new information, just as though it were rewarding in and of itself. So we may have learned to yearn to learn. We began to build things using stone tools. We mastered fire. We ended up, over the next million years, extending our childhood dramatically. We started seeing signs of cultural transmission between generations. We were finding new ways to escape the fundamental timescale of evolution. We could pre-digest our food by cooking it, develop clothing to adapt our skins without needing to evolve it. And we could make these new technologies by observing and cooperating with each other. And the more we cooperated, the more it benefited having a proto-language, the ability to signal your intentions or point things out. And over time, we think that cooperation made language more valuable, and language made cooperation and coordination more possible in a positive feedback loop. So, around 50,000 years ago, we think that complex language had already started to be used, and we were living in many small groups, each learning and sharing knowledge, each group sort of its own cultural experiment, each society working in a way that was sort of similar to a species in evolution. When some small change occurred, some new technology, they would pass on the better things to their children and maybe share it with other communities. By 10,000 years ago, all of these experiments had led to agriculture, the domestication of animals, specializations within our groups, all of the sort of fundamental aspects of our modern society. By 5,000 years ago, we invented writing, which suddenly allowed us to share all of this knowledge and information we'd been accumulating rapidly and permanently. We started trading across vast areas, living in bigger settlements, and even working already with metal. Living closer together, we formed social systems to organize our societies. We started needing to share stories and mythologies and beliefs, to pass on advice and ways of living together to the next generations. But then around 500 years ago, and probably helped by the printing press, we started to really organize all that knowledge we had accumulated, and we started using evidence to sort and verify which bits of that knowledge were really useful. And this began the scientific revolution. The 500 years from then to now is an evolutionary blink of an eye. So why did I just weave you this historical narrative? I wanted to highlight these three learning processes that shape our modern human mind: biological evolution, individual lifetime learning, and the social and societal learning, that is, the sort of evolution of culture and the effects of scientific methodology. Still, for most of humanity's time, the decisions we made pretty much only affected ourselves and a small group around us. The software that we could load into each of our children over the next generation changed very slowly, while our biological hardware has probably not changed at all in 50,000 years. In the last 150 years, society, our technology, our culture has exploded. We've become interconnected and interdependent, and our scientific methodology has allowed us to amplify our knowledge exponentially. But this rapid progress has come at a cost. For example, scientists now see humans as the major driver of planetary change, defining a new period we're calling the Anthropocene. A lot of this has to do with the fact that the learning rates of our biology, our culture, and our learning are not adapted for this rapid change we've created. Work in neuroeconomics explains how this hardware struggles and studies how it affects our software. For example, classic economics expects us to be rational. If I'm thinking about some reward in the future, I want to discount it the same amount all the way through time. So if I were to look backwards, it would be a constant process. But humans, and actually a bunch of other mammals, overweight rewards that are coming sooner. And this may be for reasons having to do with the evolutionary context our brains lived in. From this kind of understanding, we can do things like change our choice environment. So here are some behavioral economic examples that were used to try to improve our health. And these things have been studied. This is a big meta-analysis here. And the green diamonds show that even though some of these effects were small and some of the experiments didn't work, overall, they were able to show that these interventions that change our decision situation can help us make better decisions, not only in the moment, but these can have long-term lasting effects. Even the kind of thinking that may be related to attention deficit disorder has been hypothesized to have been very useful in our evolutionary contexts, but it interacts badly with some of the structures of our modern society. So while we currently do things like nudge our hardware with medicine, and we can get coaching or therapy to help us, we could also maybe modify our society and culture a little bit to help as well. Our evolutionary environment never included so many interdependent, interconnected people either. There's a number around 150 people or so called the Dunbar number that reflects the number of social connections that we can reliably maintain. And it's assumed to be about the group sizes that we were dealing with through this very long evolutionary period. But these have deep effects on how we learn to trust and understand the groups. And we're now living with more than 7 billion people on the planet. And we have not yet evolved, at least biologically, to think through these things. Even Plato thought that democracies probably couldn't function well if they grew beyond the size of a typical Greek polis city-state, 10,000 to 100,000 people. And the technologies that we create can also cause us to have bugs as well. So we've unleashed this incredible artificial intelligence that can actually fool us. It can convince us that it's human and it's only going to get better. And while it may be an incredibly powerful tool for humanity, it is very likely to take advantages of bugs in our software and biases or weaknesses in our hardware. And in fact, because it's been trained on our society's output, it's already absorbed some of the biases and bugs that we have. I don't know how to fix these bugs, but I think I have some idea of the tools we might be able to use to work on the problem. The science of complex adaptive systems provides some of the tools we need. It allows us to think about how to predict the emergent behavior of a larger system by understanding its elements, their interconnections and interactions, where each element also has its own behavior and its own ability to adapt or change. This allows us to model things like the weather or climate, or understand how the neurons in our brain produce our mind and behavior, and to think about how all of us together produce an economy, a political system, or a society. For example, in the 1970s, scientists tried to model the interactions between the economic and social resources on Earth, and they made a bunch of predictions about the future. Their predictions included good scenarios where we managed to use all our resources effectively, and a bad path called the business as usual path. It was recently updated, and as you can see by comparing the dashed and dotted lines, the model actually is reasonably successful, and that's unfortunate because it predicts, according to this measure from the model of prediction of human welfare, that things might start getting worse soon. Now, another group of scientists has done the same thing, looking at the interaction between humans and all of the dynamics of the ecosystem and the environment that sort of tells when that is stable. So the inner ring, this green area, is when the Earth is stable and our interactions with it are stable. The shaded areas that are going into red say we've crossed some boundary of stability that could cause us problems. And in fact, we have been increasingly crossing these boundaries over the last years. Now, the science of complex adaptive systems actually gives us some insight into how we can solve these problems. It's important to push all of the elements to shift the system into a new behavior, but if you push too hard, the feedback and the interconnections can cause the system to be unstable and difficult to control. It also tells us that we might want to shift away from just using the simple reductivist scientific approach, which says we can build up all our knowledge about the world by simply understanding all of its elements. It suggests that controlling these systems requires these gentle pushes in a distributed manner, and we want to maintain variability amongst the elements because that helps it maintain robustness. So, for example, a sort of rigid hierarchical control system tends not to work. Interestingly, these are all the same principles that are at work in our brain. And we can probably apply all of these to our society. We could think about education, culture, ways that we can nudge all of us, each of the elements in our system. But we would need a way to measure whether we were doing better or worse. Now, here's where modern learning theory might be able to help us. The same theories that describe how our species adapt, how we learn, and how AI works may be able to provide a way for us to evaluate when we make changes whether we're doing better or worse. Now, we would need to agree on some common measurements of what is good, and we'd probably want to do it by consensus rather than simple majority or an imperial dictate. I don't know what it would be, but maybe the UN Declaration on Human Rights could be the kind of thing we would consider. Or maybe we want to consider one of these measures of robustness and stability of the planet, or maybe both. In the end, I hope that we get to a future where we can all live happily with fulfilling, purposeful lives, and that we come to understand ourselves as both individuals and elements in this complex adaptive system, interdependent, interconnected, and working together in some also large human enterprise. And I hope that we can maintain the use of our technology intentionally as an extension of us, rather than letting it control us. And I believe the key to doing all of this will be to use the powerful learning systems that we have built into us, into our brains, into our society. But we're going to have to apply these theories to actually move ourselves in the direction we want to go in. Thank you.